So with the y equals x squared function, and we probably ought to write this is the y equals x squared function here, the point 2, 4 is on the graph. So the f of 2 point is this, or the x equals 2 point, and the x equals 2.1 point is up here. And I've got the actual graph point, which is 2.1, 4.41 marked here. And then I've got a tangent line in orange, and the point on the tangent line corresponding to x equals 2.1. Now this point should be directly above this, and the way I drew it, it didn't quite come out that way, but that's the way it should have come out. You can still see that there is some distance between the tangent line and the graph when we get out to x equals 2.1. And that distance is actually somewhat exaggerated in this picture, but we want to see that distance. So again, tangent line point is 2.1, 4.4. We can find that in a couple of ways. That just using the equation of the tangent line, we have y equals 4x minus 4. If we plug 2.1 in for x, 4 times 2.1 is 8.4, and 8.4 minus 4 is 4.4. I'm going to go off camera for a little minute and depict something here. Now I've added a little triangle here indicating the rise 0.4 between the graph point 2.4 and the tangent line point 2.1, 4.4. The rise from here to here is clearly 0.4, so we've got that indicated here. And then from 4 up to the 4.41, the rise is, and that's the rise from our 0.24, our x equals 2 point, up to the point on the actual graph, the rise is 0.41. So we can compare the 0.4 here with the 0.41 here. Now again, this looks very significantly bigger than this because I've exaggerated some things on the graph. In fact, 0.41, it only exceeds 0.4 by a little over, well, about 2.5%. So that this distance will be just a little bit greater than this distance, and this point will be much closer to the tangent line than is indicated here. Okay, so delta y, the actual change in the y, is to f of 2.1 minus f of 2, 4.41 minus 4, that's 0.41 indicated by the 0.41 corresponding to this green rise. dy is our f prime of x times dx, our f prime of 2 times dx. That's our differential approximation, and that's dx being our run, which is 0.1. That's going to be f prime of 2 times 0.1, and we've already evaluated that and obtained the 0.4. The rise of our tangent line is also 0.4. These are exactly the same because the tangent line rises according to its slope, and its slope is what determines the equation of the tangent line that determines this difference. So if you think about it, these two results have to be exactly the same. So we'll end this video clip with the simple statement: the differential approximation dy equals f prime of x dx, as calculated here or as calculated for any other function, and the tangent line approximation to dy, the change in the y value, are identical. Differential approximation and tangent line approximation are in this sense identical. And if you work through the approximations and the pictures for the other three functions, you'll get a much better sense of exactly what all this means.